Welcome grade 12 bio students. This is a special video for you for your Monday Valentine's Day lesson. So we're going to go over the biochemistry linkages and quickly review our functional groups. The problem of the day was supposed to be reviewing the functional groups here. So we've got the hydroxyl, the OH. We've got the carboxyl. The short form way is written right here, the COOH. Sometimes it's shown here like this. We've got the amino group. We've got the sulfhydryl group. We've got a phosphate group. You'll notice it has a 2 negative charge there because it's attached to something. In your note, you'll have R's, and that's great. We'll have the aldehyde group, which is written a little bit differently. It's corrected in your note, shown this way. And we have the ketone functional group. We did talk about making different types of biological linkages last week. We talked about when you have two hydroxyl groups coming together, you will form an ether functional group where the R is represented by carbons. We also have, when we have a hydroxyl and a carboxyl group, we form something called an ester linkage, which looks like this. And we have an amino functional group combining with a carboxyl functional group forming an peptide linkage or an amide linkage. In addition, we talked about forming a phosphate backbone or a phosphate ester functional group. So if you take a phosphate group, combine it with a hydroxyl group, and you'll get a phosphate ester group. In all of these, we're removing water. So you can see that highlighted in orange is the H2O that we're removing to make that linkage. And so it seems a bit overwhelming at first, but the key to understanding these is really to just know these guys right here, or sorry, these ones right here. If you understand those functional groups, you'll be in pretty good shape. If you can recognize that ether, you can recognize that ester, recognize that amide, and recognize that phosphate ester, it's really going to help you out. So let's go ahead and do some examples, and you can complete the worksheet on your own. So here what we look at, we see we have an ester linkage. It's got the carbonyl functional group, and directly to this carbon right here, right there guys, you have a double bond, or sorry, an O there, or an ether. So you have an ether and you have a carbonyl on the same carbon. That is going to be known as an ester. When we are adding water, what we're doing is we're hydrating it. And we're using hydrolysis or hydrolysis, water to split this molecule. And we're going to add an OH here, and we're going to add an H here. And you'll see in a moment when we draw it out again. So CH3, CH2, C double bonded O. And now, right here, guys, where this O is, we're going to replace that with an OH. And we have an acid functional group. Then we have 3 carbons with an O attached. So that's going to be CH3, CH2, CH2, and now I have an OH. So the water was added both here. So I'm just going to add an H and an OH to it, and that's where that's added. So we now have a carboxyl functional group, and we have an alcohol functional group. So next we have to take a look at this functional group here, and we see that we got 3 carbons, and it's a COOH. So when we look at our sheet, we will recognize this as a carboxyl functional group. So you really have to take a look at your sheet as you're doing this worksheet, understand that that's a carboxyl, and this is an amino functional group, okay, or an amine functional group. So what's going to happen is we are going to go in the opposite direction, where we're doing a synthesis reaction. So you have 2 things, and we're going to make one big thing. So to show this, what I will do is I'm going to draw out these 2 carbons. I'm keeping everything the same that I see right here. I'm going to now show this carboxyl group as an acid functional group. So it looks like this. And just to allow you to see this, I'm going to flip my molecule around. So this is now flipped. And we have NH2 and CH3. So again, all I've done is I've drawn that molecule out and I flipped the second one. Now, when you look at your worksheet that we just were looking at earlier, there's the answer there. Let's scroll up here. We have to look to see what we have to be able to answer this. And we see that we have an amino functional group plus a carboxyl functional group. That means we're going to form an amide, where the amide has a double bonded O, and instead of the C having an O attached to it, it has an NH attached to it. So let's look again. You can watch this again if it's a little bit too quick for you. But I'm going to highlight the water that I'm going to remove. So this is going to be the water that I'm going to remove right here. So we're removing an OH and an H, and we combine these two molecules together. So this would be connected there. So I'm going to redraw it so it's a little bit neater. So we got an N, we have an H, and then we have this CH3. So we have an acid right there. We have an amino right there, and we end up making an amide. So again, here's your hint in your steps, because I know some of us are going to be confused by this. You have to look at the answer sheet, which will be posted to Edsby, or sorry, in your own note. You should have this done already. And you figure out what you're starting with, and you can figure out what you're finishing with. Similarly, in the previous question, what happened was we started at an ester and we went back to the carboxyl and hydroxyl. That was the first example that I showed you. So I've been talking for about 6 minutes and 41 seconds here. So what I'd like you to do is give that a try. You can fire me a message in Edsby if you'd like. Also, the answers are going to be posted. Please take a look at those answers after you've given the worksheet a try.